morning, people. I hope you're doing well, my lovelies. But there's something speeding right by us, and it may contain science. Not to mention drama. But that comes later. Now, I remember learning about Oumuamua in 2018, shortly before the final episode of Behind the Shield's Local News from Our Universe, the segment that laid the groundwork for this series. Oumuamua, Hawaiian for Advanced Scout or Far Distant Messenger, is an extrasolar object that was discovered in late 2017 as it spent roughly 9 years flying through our solar system neighborhood from 2014 to roughly now, as it's past Neptune's orbit and is on its way to the Kuiper Belt with Planet X/grapefruit-sized black hole. If we spotted this thing in 2017, when it was already heading away from us, how do we know where it came from or where it was in 2014? Orbital dynamics and gravity, mostly. They're no fun when classifying whether or not Pluto's a planet, but they're great for determining an object's trajectory. Once we started tracking it, we could extrapolate its motion pretty effectively, and its extremely high velocity of 60,000 miles per hour, or about 100,000 kilometers per hour, couldn't have been generated from any encounters within our solar system, even unknown planets/grapefruit-sized black holes. In the words of the great philosopher GLaDOS, speedy thing goes in, speedy thing comes out. Okay, Sam, but are we sure it couldn't be a local rock? Yes. We're very sure. But beyond that, there are a whole lot of unknowns associated with Oumuamua. The first unknown was Oumuamua's gender. The International Astronomical Union was responsible for designating objects like Oumuamua, and they couldn't decide if it was a comet or an asteroid. Oumuamua, you see, doesn't have a traditional comet like C2022E3, aka Sparkly, the little green comet who rolled past us last month. Oumuamua has no tail, no bedhead of ice and dust, so that makes it an asteroid, right? Well, for the record, usually right. But Oumuamua does have one thing that isn't fully explained. Oumuamua has a speed boost. Specifically, Oumuamua shows acceleration that isn't explained by its gravitational dynamics. Now, hold up. That is not aliens. Comets have a similar speed boost phenomenon built on what's called cometary outgassing. The ice on the comet's comet sublimates and gives it a bit of a boost. Thing is, Oumuamua, again, does not have a comet. So the trick is to ask, how can an object act like both an asteroid and a comet? And that has been the topic of much publication since 2017, theorizing and creating new models to explain Oumuamua's non-binary behavior. Like, on the one hand, Oumuamua isn't like any of our more familiar solar objects. On the other, Oumuamua isn't from around here, so it's entirely possible that the conditions of its formation allowed for a different kind of object. Could it be a molecular hydrogen iceberg, for instance? Okay, no. Math says no. Back to the drawing board. And this latest paper in Nature is the product of that trip to the drawing board. The idea is that Oumuamua was an icy little part of an early planet formation called a planetesimal, then got split off by an impact onto its interstellar journey. According to this model, low-temperature cosmic radiation on Oumuamua's journey freed and sublimated the molecular hydrogen in the water matrix, giving it a speed boost. Unlike a comet's normal comet, molecular hydrogen is difficult to detect, so Oumuamua would still look like a bedheadless asteroid. This model explains Oumuamua's acceleration as well as why it looks like an asteroid but speed boosts like a comet. These findings, though, have already come under fire in the ongoing back and forth as a preprint from a researcher at Harvard and one at the Korea Astronomy and Space Science Institute brought death from above. These scientists, Huang and Loeb, pointed out that the Bergner and Seligman model didn't account for the cooling effects of evaporating hydrogen on Oumuamua itself. Just like we humans cool ourselves with sweat evaporating off of us, the process of cosmic ray-induced evaporation of hydrogen would lower Oumuamua's surface temperature, which itself would influence how the water ice on Oumuamua would ostensibly release hydrogen for the speed boost. Once all the effects of evaporative cooling were taken into account, Huang and Loeb claimed, the Bergner and Seligman proposed mechanism would no longer fit Oumuamua's observed velocity profile. Now, all of this has been so normal so far. And indeed, typically, what scientists will do is what we saw in the Venusian phosphine case. They'll publish a letter to the editor. In science, letters to the editor can be data-driven. It can include citations, all of that. And these letters might, for instance, point out issues with methodology. Eventually, the critic will often also publish their own article, at which point, if the first team has been sufficiently refuted, they'll issue a correction, or the back and forth will continue as they counter the counter, much like Team Phosphine did, and so on. You do get out in the journals. It's the done thing. Now, Avi Loeb, a named professor and former chair of the astronomy department at Harvard, straight up posted an article on Medium.com with a plain language summary of his objections. Medium.com! In that essay, Loeb says he informed one of the authors that he thought they had made an error, and received the response that no, they weren't going to issue a correction on Loeb's say-so. And because there are only two authors on this paper, Jennifer Bergner and Daryl Seligman, it was perfectly clear which author he was in this Medium.com essay. Loeb means Seligman, a postdoc at Cornell. But Bergner and Seligman, the scientists from this Nature paper, had no intention of accepting this disrespect when contacted for comment by SciComm website Science Alert. Bergner claimed they'd already accounted for several of the reasons that evaporative cooling would not meaningfully alter the conclusions. Bergner then said, "While we are happy to enumerate these reasons, we believe that letting the independent peer review process evaluate the Huang-Loeb paper is the best immediate course of action." Y'all, this is the most polite, scientifically correct burn I have ever witnessed. It is a gauntlet thrown down, my delovelies. She's saying, I could absolutely take your playground excuse for criticism and break it down like fractions to show you how it wouldn't change my conclusions one shake of a comet's tail. I would be happy to list all of them out for you like Martin Luther at a church door, but frankly, I don't even have to, because peer review is gonna laugh you out of here before I ever get the chance. And yet, like a Capulet not biting their thumb at you, sir, but biting their thumb, sir, Bergner is totally in the right. Remember, the criticism from Huang and Loeb is a preprint, which is to say that it was made publicly available on Harvard servers, but it hasn't yet been peer-reviewed or published in any journal. Preprints are the most common for papers that are considered both significant and timely. For instance, you'll see pre-printed articles published in medicine when information is urgent and physicians might treat differently based on that information. But it's a double-edged sword, because by its very nature, you can't trust a preprint. It hasn't been peer-reviewed. Now, a scholar can always choose to extend a bit of professional courtesy, basically operating off the assumption that the researchers in question know what they're doing and that the criticism they're publishing in this preprint is scientifically sound. Nah, I'm gonna wait for peer review before I clap you. Does not extend that professional courtesy, but you know what else doesn't? A full professor throwing his weight around and going after a postdoc on Medium the day after Bergner and Seligman's big Nature article is published, just because they didn't issue his correction. day one on Loeb's say-so. And at this point, I should probably tell you that Avi Loeb has his own horse in the Oumuamua race. Someone should really tell that horse to stop running. Oumuamua is definitely faster. In 2022, Loeb published in the journal Astrobiology a paper titled On the Possibility of an Artificial Origin for Oumuamua. He believes that because existing natural explanations of Oumuamua, like the molecular hydrogen iceberg, had been flawed, that artificial origins of Oumuamua should be considered. Basically, we haven't figured out by any obvious natural means, so at what point do we at least consider that it's aliens? So on the one hand, that's about the most measured take you can offer on what if Oumuamua is aliens? On the other, it means that Loeb's scholarly position gives him strong, motivated reasoning to reject new natural explanations for Oumuamua's origin and nature, especially if he really does take issue with the modeling assumptions Bergner and Seligman made. And the truth is, Bergner and Seligman genuinely might be wrong. Molecular hydrogen iceberg was a proposed model, proposed by Seligman, in fact, in 2020. And that one ultimately did have quantitative flaws. This new take might be wrong too. Maybe Wang and Loeb are right, and review will prove that Bergner, Seligman, and their reviewers really all did miss a crucial assumption that nerfs this model's accuracy. This is like a Jane Austen-style drama, where every emotion is incredibly restrained and revealed only in the smallest of ways. We're happy to enumerate our reasons, but we'll wait for peer review. Shouldn't be a gut punch, but I shrieked when I read it. And it's the drama that it is because science is a human institution, made for humans. It's not purely objective knowledge independent of the observers to know it. If the norm is to engage on the level of peer-reviewed or practically refereed literature, responding to a behind-the-scenes discussion or a preprint is a special favor, a courtesy. And then it becomes a whole big deal if you don't do it that one time, as we see here. Now, you might come away thinking that norms are overrated, and that if someone points out a major weakness in your model, even if it's not a fatal flaw, you should address it to the best of your ability because science is about truth. You might equally hear this story and see a full professor throwing his weight around and bullying a junior faculty member and a postdoc, and that norms of scientific engagement allow discourse between competing ideas to proceed in a regular manner that all parties can understand and participate in equally. Regardless of how you feel about the story around the science, and for all the spicy drama, remember people are being overtly polite and not crossing any lines, I think we can all still agree there is one place scientific discourse does not belong, and that is on medium.com. But either way, Oumuamua is out of here. We got the data that we've got, so how will we ever get answers on what Oumuamua is? Well, Loeb and Bergner and Seligman have all, at different times, supported the search for Oumuamua-like objects. Interstellar objects like Oumuamua are wildly, exquisitely rare, but various small body objects like Oumuamua could help prove or falsify the principles of a given model. I admit, it's aliens is kind of a diagnosis of exclusion at this stage, but hey, if researchers do want to look for those, I'm not going to be the one who stops you. And in the meantime, we can also look for other objects in our system that show non-gravitational acceleration, i.e. comet-like speed boosts, without traceable cometary activity, just like Oumuamua. Because however scrappy our scientists get, the best solution to their conflicts is to find out the truth. That's science, baby. More data. So, if you hear about any new binary space rocks out there, speak up. But first, maybe send it through peer review.